Defining flowcharts. A flowchart is a type of graphical diagram that represents an algorithm. It is a set of instructions that can be followed to perform a specific task, workflow, or process. This diagrammatic representation illustrates a solution model to a given problem. Flowcharts are used in analyzing, designing, documenting, or managing a process or program in various fields. Flowcharts show the sequence of instructions in a single program. They play a vital role in the field of programming. These are helpful in understanding the logic of complicated and lengthy problems. Once a flowchart is drawn, it becomes easy to write the program in any high-level language. Often, we see that flowcharts are helpful in explaining the program to others. Hence, it is correct to say that a flowchart is must for the better understanding of a complex program. Symbols used in flowcharts. Different symbols are used to draw different types of flowcharts. Let us discuss them. Start or stop. It is used to show the start and stop points of the flowchart. It usually contains the words start or stop. Process. It shows a process or action step. This is the most common symbol used in flowcharts. Decision. It indicates a question or branch in the process flow. It is used when there are two options, yes or no. Input or output. It requires material or information entering or leaving the system, that is, input and output. Flow line, arrow, connector. It shows the direction in which the process flows. Connector, inspection. It is small and is used as a connector to show a jump from one point in the flowchart to another. Connectors are usually labeled in pairs to show matching jump points. Rules to draw flowcharts. You must follow these basic rules while drawing a flowchart. The flowchart should be clear, neat, and easy to follow. Maintain the direction of the flow from left to right or top to bottom. Only one flow line should come out from a process symbol. Ensure that only one flow line should enter a decision symbol, but two flow lines should leave the decision box. Ensure that the flowchart has a logical start and end. Example 1. Flowchart to add first 100 natural numbers. Start. Sum is equal to 0, n is equal to 0, n is equal to n plus 1, sum is equal to sum plus n. Is n greater than or equal to 100? If no, then go back to step n is equal to n plus 1. Is n greater than or equal to 100? If yes, then print sum and stop. Advantages of flowcharts. Flowcharts provide following advantages. It provides a better understanding of a problem. It facilitates a programmer to analyze the problem in detail. Let us understand how some simple flowcharts are made. Example 2. Flowchart to calculate simple interest. Start. Read P for principal, small r for rate, small t for time. Calculate SI is equal to, into bracket, P multiplied by R multiplied by T, bracket closed, divide by 100. Print SI, stop. Solving problems using algorithms and flowcharts. Example 1. Write an algorithm and draw a flowchart to calculate the factorial of a number. Algorithm. Step 1. Start. Step 2. Read the number n. Step 3. Initialize I is equal to 1, fact is equal to 1. Step 4. Check if I is less than or equal to n. Then repeat step 5 to 6 until I is equal to n. Step 5. Fact is equal to fact multiplied by I. Step 6. I is equal to I plus 1. Step 7. Print fact. Step 8. Stop. Flowchart. Start. Read n. I is equal to 1. Fact is equal to 1. Is I less than or equal to 1? If true, then I is equal to I plus 1. If false, then print fact. Then fact is equal to fact multiplied by I. Then stop. Example 2. Write an algorithm and draw a flowchart to check whether a given number is even or odd. Algorithm. Step 1. Start. Step 2. Read number. Step 3. Check if number percentage 2 equal to 0. Then print number is even. Else print number is odd. Step 4. Stop. Flowchart. Start. Read a number. Is number percentage 2 equal 0? If yes, number is even. If no, number is odd. Stop.